Hello and welcome to this session. I'm really looking forward to speaking with you in the next 60 minutes about ASP.NET Core Native AOT, how to turbocharge your ASP.NET Core web APIs. Let me quickly introduce myself before we get started. So, my name is Rainer Stropek. I'm a passionate coder. I'm a passionate developer. I have been a passionate developer for over 3 decades now. I have my own company, which is called Software Architects, and I'm from Austria. That's as much as I would like to say about me, because you're not here to listen to me talking about myself. You're here to learn something about ASP.NET Core. However, if you have any questions after this talk, if you would like to ask questions or keep in contact, keep in touch with me, here are my contact details. Just visit me or link yourself up in LinkedIn and we can keep in touch. So this session has only one slide, and I will show this slide at the very end of the session. Everything else will be live coding. So from now on, we will start the slides and directly move to our Visual Studio Code. Now, when I take a look at new technologies like Native AOT, I always ask the question, why? Why is this an important technology? Why should I care? And I would like to spend a decent amount of time at the beginning of this session to talk with you about the reasoning. I would like to measure some ASP.NET Core Web API, show you the problem, and then I would like to offer you a suggested solution for that. So let's get started. The first thing that we are going to do is we are going to create a brand new Web API project. Let's do that. I will simply call .NET New Web, and here you see it is really a very simple application. Maybe we change the port a little bit. Let's listen to localhost, let's say 5003, something like this. I think this is good. And finally, we can switch from Create Builder to Create Slim Builder to make everything a little bit smaller. I think that should be good. Let's give it a run. .NET Build, first one, nothing special. .NET Run, comes up, everything fine. Let's create a very simple requests file. Requests file means I am going to use the REST client in order to do some API requests. As you can see, I am here going to 5003. Let's send this request. Okay, as you can see, works pretty nicely. Here our web API works as expected. Now let's stop this thing and publish this code. .NET publish. I would like to do a publishing with self-contained mode, so I do not want to rely on .NET in this relation. Here I'm using Windows, but you can do exactly the same on Linux, obviously. Let's put it to the out directory and let's build the Playground Life project. As you probably know, since .NET 8, .NET Publish uses the release build automatically. You do not need to specify the release configuration here. You can immediately do a .NET Publish and it should work nicely. Here you see I have my executable here, and now we can try to run it. Let's do that. Out and Playground Life. Here is the executable, it comes up, I can send the request comes back, everything is okay. I think we are good to go. Now, this is a very trivial web API, and in order to show you the problem that we have with this web API, let me add a little bit of functionality. Not a lot, just a little bit. So what I will do is I will add a modal, I will add some classes. I've prepared those classes. They are pretty simple. As you can see, we have an address, we have some contact info, we have some company info, we have an order summary, we have a customer, essentially a typical DTO, a data transfer object, as you typically have it in your web API. Now let's make this web API a little bit more interesting by adding first an HTTP post handler. Now this HTTP post handler here simply gets an HTTP post with our modal, as you can see it here. It takes the logger, writes something into the log, the customer that we got here, and finally we need a small little data structure. I will put it at the end of my program. It simply encapsulates the result of this HTTP post, as you can see it here, so I think nothing special here. I will also add another helper method, finally this one. Now this helper method, let me break it into two lines so you can see it better, will simply shut down the application. That is all that it does. If I send an HTTP GET request to the /shutdown, as you can see it here, the system will stop the application, and that's essentially it. So nothing special here. I think with that we can again give it a go and let's see what's going to happen. So let's run this thing. Good, coming up. Let's take the request file, send the request. It still works perfectly fine. And now I created a little bit more related to the requests. As you can see here, I have prepared an HTTP post request to our customer's endpoint with a lot of data, as you can see here. The data is not relevant for the problem that I would like to demonstrate to you. So here I can simply fold it. Trust me, the data adheres to our data model. Everything should be fine. We can send this thing, and as you can see, we get back an ID. In this case, we'll just get back an ID, and down here you see the log. So I think we are pretty good. The one last thing that we are going to add before we dive into Native AOT, I would like to add a little bit of data access. I am building these things step by step together with you so you can really follow what's going on in this application, and so you can really understand what the problem is and why Native AOT will really be able to be a game changer for our application. As you can see here, I'm adding the data access using Microsoft Data SQL Client, and I'm using Dapper, the micro OR mapper that many of you are probably familiar with. So again, nothing special here. And the last thing that we are going to need is a little bit of a connection string. And I have prepared this connection string. I am simply running SQL Server in a Docker container here. So yeah, essentially just a connection string. With that, we can make our HTTP post request, our handler here, more interesting. As you can see, what I do here is I'm opening up a SQL connection to my SQL server. Let me make it a little bit smaller. I hope you can still read it nicely. I open the SQL connection, as you can see it here, and then I'm going to use Dapper to run a query. Please use your imagination here. Here, your real SQL statement would be executed. It could be an insert statement, a complicated SQL query, whatever you would like to do, just imagine that it's here. In our situation, we are simply proving that we can access the database, so I'm selecting the constant 1 from the database just to prove the point. So I think with that, we should be pretty good. Let's do a .NET run. Final time. Okay, it runs. Now let's do that. Let's open the request file and send the first request, just the GET request. And I don't know if you can read it from behind, but trust me when I say this says, this simple hello world HTTP request took 92 milliseconds. 92 milliseconds for a hello world HTTP request. Now let's try to access the database. Do you see that? 1000 milliseconds. Well, maybe the database is so slow. Let's run this thing again. Oh, see? I don't think that it's the database, because the second request, which also hits the database, is 19 milliseconds. Granted, of course, the system needs to warm up the connection, the connection pool for a SQL server and so on, but still, 19 milliseconds compared to a full second, something strange is going on here. Same is true if I run this slash here. Again, if you can take a look here, 4 milliseconds if I run it for the second time. So something looks strange here. And many of you who are experienced ASP.NET Core developers will likely already know the problem here. It's a jitter, right? It's a just-in-time compiler. We have a problem here. You can imagine in your mind, or think about in your mind, how many milliseconds do you think in this simple example, which simply runs a very simple SQL statement against a SQL server, how many milliseconds do you think that the jitter takes to compile this thing to to machine language? I don't expect an answer here, but have the number in your mind. Now, let's take this example and publish it again, okay? So I will run again this .NET publish. This is the statement. I will show it to you a little bit larger. We publish it with Windows x46, 64, I'm sorry, and take the Playground Live project as you can see it here. Before, just to prove the point, I will delete the old out folder to make sure that nothing stays from before. And here we have the out folder, and now everything is much larger. If I scroll down a little bit, we have our executable and a lot of other DLLs, but still it is self-contained, so we can run it on any system. Okay, now let's take a look how much time the jitter here really needs. For that, I'm going to copy the path here of the executable, and I'm going to run a good friend of mine. And this good friend is called, let me get rid of all the windows here, a lot of windows, as you can see it here, Purview. If you don't know Purview, get Purview. It's the best UI in the world. I think, no, I'm just kidding. It's not the best UI, but it's a really, really nice tool. Let me quickly run Purview for you. Okay, here it is. And I have to zoom in because, trust me or not, this is not, I cannot increase the font here. So I have to work with the zoom here. So what I'm going to do is I'm going to run our executable that I just created in Purview. Let me store the data in the correct folder, and let me show you what we are going to do. We don't need to zip it, we don't need to merge it. Isn't that a beautiful UI? It's a UI for developers, right? I love this UI. You can hover over any of the settings and it will tell you exactly what's going on, but for now, trust me, it makes sense what I selected here. I think it should be good. So let's run this thing. This will now start the application, and I can go back into my Visual Studio Code. It is here, and it should now run the application inside of Purview, monitored by Purview. So let me run this request. You see, it still returns. Let me run the database access. It still returns. Looks good. And now let's shut down the application. The last request shutdown will terminate the executable, and that will make sure that Purview is now gathering all the telemetry data that we are interested in. Now we are waiting and waiting and waiting. It still takes a few more moments. Now we can open it, go to advanced, and here we go into the JIT stats, just-in-time compiler stats. And then we go here to the Playground Live, and believe it or not, over 1 second of the entire CPU time of our simple cold start was used by the jitter. So 83% of the total process CPU was spent by the jitter. This is a pretty astonishing amount. Granted, we don't do a lot of work in our application, but for such a simple Hello World application, we are using a second. And if you take a look at the different libraries, you see that the system uses for the core lib approximately half a second for jitting time, SQL client uses a third of a second, and so on and so on. You can try this experiment at home with Purview. It really shows the problem here. The jitter is really the problem. However, I would like to know more. Before we go into Native AOT, let's add a little bit more of telemetry to our application to know really exactly where our problem is and what the performance metrics of our application are. Because if we go to our customers and tell them, hey, we can get rid of the jitter with Native AOT, they are not going to believe us that they will really feel a difference. So let's see what this jitter CPU usage, how this jitter CPU usage translates to real performance measurements. So what I'm going to do is I'm going to add a little bit of code to our small little sample application. We are going to add event tracing. If you're not familiar with event tracing, look it up after the session. It's a super useful tool. I am going to add, as you can see, a class, which is pretty simple. It just derives from event source, and it has, as you can see it here, 3 methods. It has one method ready to receive, it has one method start request, and it has one method end request. So this helper method allows us to write event traces into an event log, which we can then gather using Purview. This is what we are going to do. The first thing that I'm going to add is I'm going here right in front of our app.run statement here. We are going to write one log message that we are now ready to receive HTTP requests. This event will be super interesting when we ask the question, how long does it take between running the program and being ready to receive HTTP requests? That is the first log that we write here. And the second log is something that we put into our pipeline, into our HTTP pipeline. I'm using use here, and before every incoming request, I'm starting the request by writing a log, then I'm executing the HTTP event handler, and then I'm writing the end request into the log, as you can see it here, and finally I return the original response that the event handler produced. So that will give us a nice telemetry data about how long every single HTTP request really took. And with that, let's build everything, let's publish everything, and let's rerun Purview, and let's see whether we see still the same problem. So the first thing is I'm going to delete the out folder again, and I am going to publish everything. We did that before, nothing special. Okay, we now have our application in the out folder. Now let's go back to our friend Purview, and I think I messed up because I stopped Purview again. That was not a good idea, I'm super sorry, but now I started it again. Collect, here we are. I have to run it in an administration mode, and I will paste in the path. Let me zoom in, so you see this is exactly the file that we just created. You do not need to see all the difference, or all the details. I will zoom in whenever it gets interesting, and it gets interesting now. Exactly, here we are. The change that I just did is this one. I'm now telling Purview that I'm writing event traces into the event tracing system of, in this case, Windows. So when we take a look at the Playground Live, you will see that I added here the event source name Techorama 2024. And this is exactly the additional provider that I specify here. So I'm asking Purview to gather these event traces so that we can take a very close look at what's going to happen. With that, let's run the application. It will run in the background, so I can get my request file. Here it is. Let's send the first request. It works pretty nicely. Let's send the database request. It works pretty nicely. Let's shut down the application. Let's go back to Purview. It will again take a moment. Here it is. Don't worry, I will zoom in this beautiful UI in a second. Good, here we are, and this time I'm not interested in the jitter, I'm interested in the events. Here you see the events. Let me zoom in here so you can see what's going on. I'm going to do a process filter here, and I called it Playground Live. This is the name of my executable. And then I'm going to filter the event types. I'm going to say process/start, because this is the first thing that I'm interested in. Then I'm using the pipe or Techorama 2024, because that is exactly the event tracing provider that I used. Now I can click on all the events that I'm interested in, press the Enter key, and now we see exactly what's going on. Isn't that a beautiful UI? I really like it. Now let's take a look what we have here. Let me zoom out a little bit. Let me run the calculator. because I'm not very good in doing math in my mind, especially when I'm standing on the stage, on such a large stage as here. Let's do this one and zoom in again. So let's see, between the process start that you can see here and the ready to receive, we have how many milliseconds? 1113.568 minus 697 comma 151. So we have approximately half a second that the system needs in order to getting ready to respond to HTTP requests. 400 milliseconds. You know what? Let's write that down, because I'm pretty sure in a few more minutes I cannot remember the time anymore. Timings. So let's write that down. That was to get ready. It took us how much was it? Yeah, 416 milliseconds. That's the first thing that I'm interested in. Now the second thing that I'm interested in, let me zoom in again, is the duration that our very simple request, hello world, just returning a constant string took. So that's 6,491.081 minus 6,482.280, and that is approximately 9 milliseconds, okay? I can remember that, and let's try the last one. That's 10,942 minus 10,034, something like this, approximately a second, approximately 900 milliseconds that our request took. So the slash took us approximately 9 milliseconds, and the slash customers took us approximately 900 milliseconds. So now we have some benchmarks. And this is exactly the problem that we have. We have a lot of CPU time going into the jitter, and we have a pretty poor response time to get ready until we can serve HTTP requests, and the first requests are really slow. I showed you that all subsequent requests are pretty fast, but those first requests are pretty slow. And the question is, what can we do against that? Native AOT is exactly the answer. So what do we have to do in order to make our application ready for native AOT compilation? Well, the first thing that we need to do is we need to change a little bit in our project configuration, and in this case I am adding two settings, and you see these two settings here. The first one is mandatory. I really have to change that one, publish AOT, that enables native AOT compilation. The second one is just there so that I can use event tracing and purview to take a look at the performance details after we compile everything ahead of time. So that is essentially all that I need to do. Well, there is more to do, but I will show you that in a second. For now, it's good like that. Let's simply try this thing. Let me delete the out folder again, and let me redo the publishing. Now you see, publishing starts, publishing starts, publishing starts, and at one point in time, yes, this is exactly what I wanted you to see. This is new. We haven't had that before. This step, generating native code, is now there because we enabled native code. What the system now does, it does all the heavy lifting that it normally does during jitting at runtime at compile time. So it takes all our code and generates a native executable for the target platform, be it Linux, be it macOS, be it Windows. In this case, I'm using Windows here because I run Purview on Windows, therefore I use Windows. Normally I use Linux for developing, but that's really not the point here. So this is what you do, and as you can see, it's still not completed. So that's the first takeaway that you can take away from this demo. AOT compilation isn't fast. You need a powerful laptop, not like the one that I have here, which is pretty hot now and probably it takes a while. So compiling everything down to AOT takes a pretty long time. And the second thing that you are going to see here is that we see a lot of warnings here. What's going on? Why do we get so many warnings? I mean, the code isn't perfect, but still the code isn't horrible. Well, all these warnings come because native AOT compilation does assembly trimming. That's the second super important takeaway that you have to take away from this session. So is a native AOT compilation something that you can do? It depends. If you're using libraries or if your code is not trimmable, then probably native AOT is not possible for you. And I'm super sorry to say that a lot of the libraries that you know and love are not ready for native AOT as of today. Do you like Entity Framework Core? I'm super sorry you are not able to use it because it's not ready for native AOT. Do you use, I don't know, something like OpenAI and you're using function calling? I'm super sorry, the .NET library for OpenAI is not native AOT compatible. And probably many of your other applications that you use or libraries that you use are also not ready for native AOT. So as you can see, it took a while, but at the end of the day, we got a single executable, and luckily, many of the things that I'm using in this application are compatible with native AOT. At the end of the session, I will show you a link where you can look up exactly which libraries Microsoft currently supports for native AOT. But the important thing that I would like to do now is to find out whether it still works. And spoiler alert, it doesn't. Let me show you why. So let's run this guy out, playground live. Yeah, it came up. Let me use the requests. Let me do that one, and we got an exception. Here it is. This is the problem here. Now, the reason this application currently crashes is that we are using JSON at the end of the day. Let me show you the program. And the first request, it was that request here. Oops. Sorry. Now I sent it correctly. The first request is simply turning a string into JSON because we want to return a string in JSON format. And the problem with the JSON serializer is that the JSON serializer uses reflection. Reflection is not compatible with assembly trimming. .NET Native is built on top of trimmed assemblies, therefore we have a problem. You do no longer have reflection when you do native AOT. You do no longer have any functionality of the jitter at runtime. So you cannot dynamically load a DLL, a .NET DLL at runtime. It's simply not possible because the jitter is not there. There isn't anybody who could translate intermediate language into machine language. And the most important thing, I repeat myself, you don't have reflection. So whatever you want to do with native AOT, you have to do it at compile time, not at runtime. And this is the reason why so many libraries are not ready for native AOT. Every library that makes heavy use of reflection has to be rewritten or in some way re-architected. And I'm going to show you how Microsoft did it with JSON. Well, essentially this is not something that came with .NET 8. It's older, but now we are benefiting from it. Let me show you how we can get rid of this problem. I am going to copy a little bit of code into our tiny little application. As you can see it here, and what you see here at the end of the day is you are going to see JSON serializable attribute with the JSON serializer context. You will see in a second what this JSON serialized attribute does if you don't know it so far. So the second thing that I need to do is I need to make sure that ASP.NET Core knows about this serializer options. So what I'm going to do here is I'm telling ASP.NET Core that it can get type information, as you can see it here, for the JSON serializer from this class down here. This is the class. And this class is currently empty. It is filled by a source generator. The source generator is doing the operations that typically are done at runtime using using reflection. But now it's doing its job at compile time, and therefore we don't have the problem with the the runtime reflection anymore. And that's exactly what we want, right? Let me show you what's going on behind the scenes. So I'm super sorry for the sound. It's not on my side. I will try again something. I don't know what's going on here. So I compile it again, and now I'm zooming in a little bit here. Whoop, here it is. Sorry, I forgot something. In order to be able to show you something, I need to change something with the CS project file. There is an additional setting here, emit compiler generated files, as you can see it here, and that will help me a lot when I demonstrate this thing here. So now we are good. And here we are, and here we have generated, and here we have this one, and let me show you what you see here. In the generated folder, you see a lot of generated code. And you see, for instance, that we have an app.json serializer context for the string. See it down here? Or for the customer, or for the contact info. And that's essentially what the source generator does. The source generator does reflection at compile time, and it generates the necessary type information for us. So if I take a look in the generated customer class and scroll down a little bit, you see here is the customer ID, here is the first name, here is the last name, and so on. It's essentially generated metadata at compile time instead of reflection at runtime. And this is exactly what we need in order to make our application compatible with native AOT and assembly training. So keep that in mind. You have to get rid of reflection by doing source generators. That is a prerequisite to benefit from native AOT. So now it should really be nice. And the last thing that I would like to add is a little bit of data access with Dapper stuff. And luckily, the Dapper object relational mapper that you might know, it's a micro object relational mapper, much smaller than Entity Framework. It already supports AOT. So we can do AOT with Dapper and therefore access the database. There is one tiny little problem, which I will talk about in a second. Let me add one final code file here. By the way, I have, of course, my entire code on GitHub. So at the end, I will show you a QR code, and you can take a picture of that QR code and to see the entire code in GitHub. So you do not need to make notes here. So what I did is I added a tiny little code file here to let Dapper know that I'm using it in the context of native AOT. You can look that up in the Dapper documentation. It's really a very simple thing. Okay, I think we are good to go, and now we are going to rebuild everything, and let's see if that really made anything better. So here we are. Let's do the publishing again. I deleted everything, so this should now be native. Oops, what do I have here? Oh yeah. I forgot one saying, and I will not tell you what this saying does, because that will be the last thing that I'm going to talk about. For now, it's just a magic setting that makes everything good. Generating native code. Wonderful. And now we need to be a little bit patient. And let's use this patience to take a closer look at all the different warnings that you see here. And the most important warning is this one. I have not a very good news for you. Microsoft SQL Client is not ready for AOT officially. It works, you will see, I can access the database, but many of the functionality or some of the functionality of Microsoft Data SQL Client is not compatible to native AOT. So you have limitations when accessing a database from a native AOT compiled application. So the message that I'm giving you here is that even some basic functionality that you typically expect from a system to have is not there yet. So Native AOT is a really nice feature, but .NET 8 was only the first step into this direction. Well, it was not the first step. The first step was earlier when console applications became ready for Native AOT. Now we have parts of ASP.NET Core ready for Native AOT, but still there is quite a way to go in order to use Native AOT for real-world, non-trivial applications. So you have to spend a little bit of time analyzing whether your application fulfills all the requirements that you have in order to work with Native AOT. However, everything worked now. Let's take a look whether it really became better. So let's run this thing out. I'm going to run the Playground Live executable. It comes up. That's a good point. Let's open up the requests and let's do that one. And the first request was 14 milliseconds and the second one here was 200 milliseconds, as you can see it here. And if we compare that with the timings, before we had 900 milliseconds, now we have 200 milliseconds, and that's quite impressive. That's exactly the same scenario, right? We have the same database connection, we have the same code, I changed nothing, I simply switched to ahead of time compilation, and instead of 900 milliseconds, it now took us only 200 milliseconds if we just take a look at the client. And if I take a look at the time, I think we can also try it with Purview and take a look when we also see a difference in Purview, okay? Because this thing was measured in Purview, so we want to compare apples with apples. So let me run this again. Oh, I don't need to run it, sorry. I want to run it in Purview. Here is Purview. Let's go into Purview. Let's go into Collect and run this thing. The only thing that I need to change here is I need to get rid of the check of .NET here, because from the point of view of Purview, this is no longer a .NET application. This is no longer intermediate language. This no longer has .NET built in. It's now pure assembler code. It's like if you would take a Go application and compile it down to assembler code. It's like if you take a Rust application and compile it to assembler code. It's really just assembler code. So therefore, I have to get rid of the .NET here, and there is no jitter anymore. If you ask me for jitter stats, I don't have jitter stats for you because there is no jitter anymore. Everything is done at compile time. So let's run this guy. Good. Let's go back to our application. I hope it works. Yep, it answers. Yep, it answers. Perfectly fine. Let's shut it down. Let's wait for Purview to gather all the events for us. Here we are. Let's take a look at the events. And again, filter. I will not zoom in because I do the same filtering as before. So Playground Live is the first thing. And I'm going to say process start Techorama 2024. I will select this, enter, and zoom in. Here's the calculator. Let's take a look. This example here is the first call to our customer's endpoint, 7491, 220 minus 7467. Oh, sorry. 7467, 554, and let's see, 23 milliseconds. 23 milliseconds. May I remind you what we had before? 900 milliseconds. So within ASP.NET Core, not measured end-to-end from the point of view of the client, we really have a significant difference when we take a look at the performance measures here. I could do it again if you run this test many times and you have a larger base of data. You can do a little bit of statistical analysis, and you will see that Native AOT really makes a difference. I mean, it must make a big difference. But I think this small sample here really drives the point home. You see, even in such a small application that contains only a few lines of .NET code, we are really seeing a huge difference when using Native AOT compilation. Now let's talk, now that we saw how it works, how we can turn to AOT and what the problems are, let's talk about how Microsoft makes the magic work. How does this work? What do they do in order to really get this thing going? And the first thing that I would like to show you is a small application, or the output of the compiler, let's put it that way. Here the release is generated, and let me show you exactly that one. This is the generated code that was generated for our Dapper data access layer. And one thing that you might immediately see when you take a look at the generated code here is that C# and .NET generated an interesting attribute on top of the generated class, and it says intercepts. Now, interceptors are the really interesting new feature to C# that make native AOT and ASP.NET Core and many future scenarios possible at all. So let me demonstrate to you what the intercept attribute really does. And for that, I would like to switch to a second project here and show you that in a very, very simple console application. I just created a console application, super, super simple. Now, the first thing that I am going to do here is I'm going to add something to a system namespace. Yes, you heard me correctly. In my own application, I just created an attribute, the intercepts location attribute, inside of system runtime compiler services. Why is that necessary? Because as of today in .NET 8, interceptors are not finally released. They are a preview. So this attribute that is the basis for native AOT in many scenarios is just a preview in .NET 8. You have to wait for the upcoming releases in order to get this attribute with a final implementation. As of today, if you would like to use interceptors in your own application, you have to create this intercepts location attribute on your own. It's empty. As you can see, it has an empty constructor, nothing else. That's all you need to do. Well, there is one second setting that you have to do, and this is now the magic setting that makes everything possible. I did that before, and now I can describe it to you. You also have to opt in into that preview feature. So what you have to tell Microsoft .NET, you have to say, okay, you know what, .NET, I know that interceptors are preview, and I still would like to use it. But in this case, I am using it in my own namespace, which I will call my app. I'm opting in. I say which namespaces are allowed to use the new interceptor feature. This is what I did here. And now let's use this interceptor feature. Here it is. So this is the wrong folder. Let me copy the path. Let me change this one. Now the warning should be gone. Okay, let's take a look. This is our application. As you can see, in line 2, I have a console write-line statement. The call to the write-line method, as you can see it here, is, I'll zoom in for you, in column 9. So let's scroll down, and here I'm defining my interceptor. I'm essentially telling C#, hey C#, ignore the call in program CS, line 2, column 9, and whatever's written there, I don't care. I would like to replace it with this business logic. That's why it's called an interceptor. It intercepts the call. So now listen closely. I'm choosing my words carefully. By adding code, we are changing code. You know why this is important? You know, source generators, like the one that I showed you with the JSON serialization, they can only add code. Now Microsoft has a problem. At certain states, at certain areas in your application, Microsoft needs to change the behavior of your application depending on whether you are in native AOT mode or whether you are in just-in-time mode. But a source generator can't do the job because it can only add code. It cannot change code. That's not supported with source generators. And interceptors are the magic trick that come in. You can now add code And this edit code changes the behavior of the application because it intercepts existing calls. That's the whole idea. So check out what I did here. I simply add intercepted colon here. So if I run this thing, .NET run, you will see that we get intercepted. See? That's the point. That's the point of the interceptor. Well, obviously, nobody is going to write this code by hand. I just added this code for demonstration purposes so you really understand what interceptors are in the background. In real world, these interceptors are generated code, and that is exactly what systems like Dapper do. They create a call to the intercept location attribute, and at the end of the day, they are changing the call in line 27. Let's take a look what we have there. Program CS, line 27. Where is 27? Here it is. They are essentially replacing the database query with additional or changed code which is compatible to native AOT. And the same is true not just for Dapper, but also for the generated route builder. Here you have it. Here you see the intercept location attribute, and this is somehow intercepting a map get call in line 19. Let's take a look at line 19, what we have there. In line 19 here, we have the very simple get / command. Now, why? Why does ASP.NET Core intercept the map get call here? Where is the problem with this map get call? Let me demonstrate to you what the problem is. I will do that in the console application again. Now I hope you understood the interceptors because I'm going to delete this thing. Let me write a very simple class, static demo class, whatever. And let me add a public static int to something. It gets some data, some string. It gets a double, some double, and it simply returns an integer value. Very, very simple stuff. Now, if this would be an event handler in ASP.NET Core, let me show you what ASP.NET Core does in the background in order to access this method. So in our real application, it would be something like this, or something like this. And ASP.NET Core has to be able to take a look at this method and say, oh, there is a customer. So Rainer seems to want to have the HTTP request body to be turned into a customer. Rainer wants to have a logger. Rainer wants to have access to configuration data. So ASP.NET Core needs to take a look at this data at runtime, and that's the problem. So what ASP.NET Core essentially does, ASP.NET Core is using the delegate class, let's say func, and we can simply assign the demo class dot do something here. As you can see it here, no call. And then we are simply write parameters on the screen. We are going to say mi equals to func.getMethodInfo. So this is just reflection, and then it takes the parameters, it writes all the parameters on the screen. That's essentially what I do. So if I say .NET run again, you will see that now I get here some string, some double. I can reflect the method down here and find out what the parameters are. And this is exactly what ASP.NET Core does out of the box in order to call your event handlers. It takes a look at the different arguments and does the necessary mapping. It understands what is the HTTP body. It understands what comes from dependency injection. It understands what comes from configuration or logging infrastructure. But as I told you, with native AOT, we don't have reflection. So therefore, if I take a look at this code, we really have a problem here because this is reflection. So ASP.NET Core is not compatible with native AOT. And what did Microsoft do? They created a generator. They created a source generator that can rewrite ASP.NET Core fundamentally by creating an injector. Interceptor, sorry, interceptor, I used the wrong word. So if we take a look at this code again, you see it now intercepts our map get. If I take a look a little bit further below, you will see that this is our map post. See, this is line 21, that's the HTTP post that you saw before. If I take a look, this is the second map get. This is the one with the shutdown stuff. So the generator is replacing the entire reflection logic that normally works at runtime. And that's the magic that is making ASP.NET Core possible with Native AOT. And that is how C# and .NET will go forward. Additional teams will need to write source generators. Those source generators will need to rewrite your application, hopefully without you having to change anything in the code. And they are using interceptors in order to rewrite, in order to reinvent the behavior of your application. That is essentially what's going on. So far, you have seen that without Native AOT, we are spending a heck of a lot of time with just-in-time compiler, and it takes quite a while to even send a single SQL statement to the database. With Native AOT, we could reduce the startup time, the cold start time, significantly. So let's wrap up by taking a look at the slides that I prepared. So where is my slide deck? Here is my slide deck. And let's do the one slide that I created for you. Oops, here it is. Why should you care for Native AOT? To reduce cold start time. Will it enhance the overall performance of your application? No. It could even decrease the performance of your applications a tiny, teeny little bit if you do Native AOT compilation. So don't use Native AOT if you do not have a cold start problem. When do you typically have a cold start problem? In the cloud. If you have an elastic infrastructure that adds additional workers depending on the load on your web API, then Native AOT can be really interesting because it allows you to very aggressively shut down instances if they are idle, because they will come back pretty fast. So that's the first thing. If your problem is cold start, then it might be interesting. It might also be interesting if you have a memory problem, if you have too large memory footprint, or if you simply want to keep your container images, for instance, small. Many applications, depending on the workload, many applications are smaller if you do Native AOT compilation. That's not always the case, you have to measure, but in many situations it is. Is it good for everything? Absolutely not. So let me show you this link. I added this link to my slide deck, and here you, for instance, if you scroll down a little bit, here you see a table. I will not read it for you, you can read it on your own. Here you see a table with different features of ASP.NET Core, which are partly compatible, fully compatible, and not compatible at the moment. And in not compatible, you see a bunch of really important restrictions. MVC, not supported. Blazor server, not supported. SignalR, not supported. Other authentication beside JWT, not supported. So, as I told you, this is not what I call everyday C#. Not every application should immediately turn to Native AOT. You should be careful in thinking about when to use this feature and when not. But if you ask me, in the future, we will see more and more libraries going towards Native AOT because it has a lot of advantages. Finally, my last thing here is test your apps before you put them into production. Because if you do .NET Run, you are not executing ahead of time compiled code. If you do .NET Run, .NET will only emulate the behavior of Native AOT compiled code. It is very likely that you can find all the bugs if you simply run .NET Run or press F5 for running the debugger, but at the end of the day, and I had that myself, there is a difference when you execute the application really with Native AOT compared to .NET Run. So you have to do extra testing. Better safe than sorry, as I wrote it here. Now after this talk, where can you learn more? I have this link here which leads you to learnmicrosoft.com, to the whole documentation. I'm also more than happy to share the entire code that I just created. And finally, I recorded this session. If the recording went well, I will put this session onto YouTube. I know I did a lot of demos, I showed a lot of tools. If you want to revisit what you just saw, if you would like to refer it to a colleague, for instance, who might also be interested in this topic, feel free to point them to my YouTube channel. If everything goes well, I will probably put it online in the next few days. With that, I think, yes, we are nearly out of time. I have time for 1 or 2 questions. If you have questions, just come to me, to the front. We can have a quick chat. From my side, thank you very much for visiting my session. I hope you took something away from the session, an insight into native AOT, or maybe a tip or a trick, a tool that you just saw. Thank you very much for coming. Enjoy the rest of Techorama. Have a beautiful evening.